Students, in lesson 5.1, we are going to be working on algebra, and specifically we're going to be looking at division patterns with decimals. Our essential question that will guide our understanding throughout this lesson is, how can patterns help you place the decimal point in a quotient? Boys and girls, remember, quotient is the answer in a division problem. So I'm going to write down, just to remind myself, answer in division problem. So we are going to start with the real world unlock the problem. On the blue box on the right hand side, it's asking us to do some things. It says underline the sentence that tells you what you're trying to find. And secondly, it said circle the numbers you need to use. So I'm going to start over here, and I hope that you will follow along with me. The Healthy Wheat Bakery uses 560 pounds of flour to make 1,000 loaves of bread. Each loaf contains the same amount of flour. How many pounds of flour are used in each loaf of bread? So boys and girls, we are going to underline the last statement of that problem because that is a question, and that is what we're trying to find. Also, boys and girls, we're going to circle 560 and 1,000. And also, boys and girls, as math detectives, I want to prompt you to see the word the same. Whenever you're seeing the word same, you're thinking division, because that means we're going to equally divide something up. So whenever you see same, you should be thinking this must be a division problem. So boys and girls, it says you can use powers of 10 to help you find quotients. Dividing by a power of the 10 is same as multiplying it by 1/10, 1/100th, or 1,000. And boys and girls, when you multiply by a decreasing power of 10, your answer decreased. That's the same thing that will happen to your quotient. Your quotient, boys and girls, will decrease. So I'm going to write that out there just to keep that in mind as I go through and I solve this first problem. So one way is we're going to use place value patterns. So that's the first strategy we're going to use today. So we see 560 divided by 1,000. It says look for a place pattern in these products and quotients. So we're going to start always with our benchmark number. So you might say, well, why do I do this as my first one, Miss G? The reason why you do this as your first one because your first factor is 560 times 1 gives you 560, and that is the identity property of multiplication. So 560 times 1/10, you would lose one decimal space and you would move to the left. 560 times 100th, you move 2 places to the left, and 560 times 1,000th, you move 3 decimal places to the left. And just something I'm going to do in parentheses, boys and girls, is I'm going to write down how many place values we're moving to the left, because that's a good practice that we started in the previous chapter, which we can do again here. So now, guys, we're going to think about division. When we think 560 divided by 1, we would get 560, because 560 times 1 would give us 560. And we can see that right here on the left-hand side. So, boys and girls, when it says 560 divided by 10, we would get 56. And we can see here on this side, boys and girls, 56 times 1/10 will give us 560. So if we do 56 times 10, we gain a 0, and you see that there's an additional 0 there. Or you can see a 0 here minus a 0 here. There's no zeros in our product. So I'm going to write that down there so we can see that. Also, boys and girls, we're going to go on to the next one. 560 divided by 100. Boys and girls, notice here. 1 0, 2 zeros, 1 0 in our product. 560 divided by 1,000, it is 560 thousandths. And you see it's dividing by 1,000, we lose 3 place values. So just like in the previous problems, we lose 3 place values, we lose 2 place values, and we lose 1 place value. So 56 hundredths pound of flour is used in each loaf of bread. So boys and girls, it is asking us to analyze and see the patterns here. It says, as you divide by increasing powers of 10, how does the position of the decimal point change in the quotient? So what I would do is I would say, we saw the decimal point kept moving to the left. So we would write down the decimal point moves 1 place to the left for each increasing power of 10. Now, boys and girls, on the bottom here it says, remember, the 0 power of 10 equals 1. So the 0 power of 10 is equal to 1. The first power of 10 equals 10. Because this is like saying 10 times 1 is equal to 10. This is something important to commit for memory. You might even want to make a note card for yourself. So boys and girls, another way to solve these problems is we can use exponents. So it says to divide 560 divided by the 3rd power of 10. Now what we can do, boys and girls, is we can look for a pattern. 560 divided by the 0 power of 10, which is 1, would give us 560. In green, boys and girls, I'm going to evaluate the exponents just so I can keep it clear in my head. So the first power of 10 is equal to 10. 560 divided by 10, we would lose 1 place value, so we would move 1 place to the left. And notice the reason why we move 1 place to the left is that there is 1 0, which I'm going to circle a different color. Now, boys and girls, we go on to the next. The second power of 10 is like saying 10 times 10, which is 100. If you divide 560 by 100, there's 2 zeros, so you know that you're going to lose 2 decimal places, and you get 5 and 60 hundredths. Now, boys and girls, the third power of 10 is 1,000, because 10 times 10 times 10 is 1,000. And there's 3 zeros here, so that means that we're going to move and lose 3 spaces. So basically, again, boys and girls, in parentheses, I'm just writing what we lose. If we lose 3 spaces, I'm going to write down the original number, which was 560. And if we move 3 spaces and we lose 3 spaces, 1, 2, 3, our answer would be 56 hundredths. And you can drop the 0 if you want, boys and girls. You don't have to stress about the 0 there. It is just a place value holder. So the next question, boys and girls, says each divisor, so all of this, boys and girls, all of that is considered to be the divisor. Boys and girls, all of this is our dividend, the thing that we're dividing up. And remember, again, all of this is our quotient. So I'm just going to, it's good practice when I'm just reminding myself, because division can be sometimes challenging, especially if you feel as though you struggle with multiplication sometimes. It's never a bad idea to keep everything in line and label it again. So it says each divisor or power of 10 is 10 times the divisor before it. How does the quotient compare? So although the divisor is 10 times, boys and girls, we can see that each quotient is less. So we can say that each quotient is the opposite of 10 times, boys and girls. Do you remember what that is? 1/10. That is correct. And I'm going to put it in decimal and in fraction form of the quotient before it. Now, boys and girls, we're going to go on to our next problem, which is connect. it says dividing by 10 is the same as multiplying by 1/10. So it says, or finding the 10th of a number. And this is why I started to write these down together, because I want you to connect them and not stress out when you see them and know, oh, these are related. This is something Miss G's been working on with us. So we're going to start with this example here about Lang. So it says, Lang used 25 and 5/10 pounds of tomato to make a large batch of salsa. He used 1/10 as many pounds of onions as pounds of tomatoes. He used 1/100 as many pounds of green peppers as pounds of tomatoes. How many pounds are in each ingredient that Lang uses? So boys and girls, I'm going to underline this last statement because this is what we're trying to find. Also, boys and girls, I'm going to go back into the original problem and I'm going to circle the numbers. So I have 25 and 5/10, 1/10, and 1/100. And to remind myself that 1/10 can look like this, or fraction form, and then 1/100 can look like 1/100th or 1/100th in fraction form. So boys and girls, what it says we're going to do is tomatoes. We have 25 and 5/10 pounds, and it says 25 and 5/10 pounds divided by 10. Now we know that it's really not 10, we know it's a tenth, but we can start there as our benchmark number. It says think 25 and 5/10 divided by 1 would be the same number, which would be 25 and 5/10. So 25 and 5/10 divided by 10, boys and girls, means that we would lose one decimal place because there's 1 0 there, and we would get 2 and 55 hundredths. Next, boys and girls, we are over here where it says 25 and 5/10 divided by 100. We know it's not 100, it's actually 1/100th. So we're going to start with 25 and 5/10 divided by 1, which would give us 25 and 5/10. Now remember, our dividend is going to stay the same. So we're going to say 25 and 5/10 divided by 10. That's 1 0. That means we move one place. We get 2 and 55 hundredths. Again, our dividend is the same. 25 and 5/10 divided by 100. There's two zeros. So that means that in a benchmark number, we're going to move, again, 2 zeros. 1, 2. And we get the answer of 255 thousandths. So, boys and girls, Lang used 25 and 5/10 pounds of tomatoes, 2 and 55 hundredths pounds of onions, and 2 and 255 thousandths pounds of green peppers. Now lastly, boys and girls, it says complete the pattern. When we start here at the top, we know that the benchmark is nice and easy because any number divided by 1 is that same number. So 32 and 6/10 would be 32 and 6/10. Now 1 0, boys and girls, that means that we're going to move one place over, and we're going to get 3 and 26 hundredths. And now, boys and girls, if we have 32 and 6/10, and we have 2 zeros here, that means we're going to lose 2 places. So we would go 1, sorry, let me start here, 1, 2, and we would get 326 thousandths. Now, boys and girls, keep in mind that, again, this is our dividend, this is our divisor, and lastly, this is our quotient. Now, again, this is our dividend, this is our divisor, and this is our quotient. I like to always evaluate the exponents out. The 0 power of 10 would be equal to 1, boys and girls. So 50 and 2/10 would be 50 and 2/10. Next, boys and girls, the first power of 10 would be 10. So there's one place of 0 in there. So we're going to lose one place. So we're going to move, and we get 5 and 2 hundredths. And lastly, boys and girls, the second power of 10 is 100. 2 places there. We lose 2 places. 1, 2, and we get 502 thousandths. Take your time with this video.